So I've started the recording. No problem. After the control chart part is done, so this is a control chart. Anything which lies outside these control limits is called as an assignable cause or outlier or special cause. Why is it called as assignable cause? Because we can assign some reason on why this is an outlier. And we also ensure that data is random and the process is in control. Only if there are no assignable causes, if all are eliminated, and if you see that there is no particular pattern, 1 point up, 1 point down, 1 point up, 1 point down, this is called as data following some trend, some format. It should not be like this. Data should be random. And if all the data points are falling within the control limits, then we go ahead with the control plan. Right? Once that is in place, once all the data points are falling within the limits, control measures need to be taken to maintain the process as desired in the long run. So in the long run, you'll be able to maintain these measures. UCL, LCL, you'll be able to maintain it in the long run. A control plan is formulated to maintain all the improvements except those where mistake proofing is applied. Wherever mistake proofing or Pokayoke is applied, you need not document that, or you need not formulate anything in the control plan for that. As I was telling, even in the traffic, even in the highways, right, wherever we have the street lights, etc., those street lights switch on itself when the vehicle moves on the road. When there is no vehicle moving on the road on that direction, the street lights will be switched off. That is a way of mistake proofing the electricity usage. So in this way, if there is any mistake proofing or Pokayoke done, you need not formulate it in your control plan. None of the vital x's should be ignored for improvement. In y is equal to f of x, there could be multiple critical x's. Critical x's only, right? None of these should be ignored for improvement. You have to try and improve each and every critical input or vital input. The existing control systems and procedures of the process must incorporate the control of x's. You might already be having existing systems, existing processes, procedures, guidelines, right, which were already established previously. You need to incorporate the control of inputs into these existing procedures. Now the responsibility of ensuring that the control plan is followed must be transitioned from project leader to the process owner. Now here is where you as a Six Sigma consultant will hand over the improved process along with the control plan to the process owner. And you move on to the next project. And you leave it to the process owner to continue. Need of a control plan in case of vital X drifts. What do you mean by vital X drifts? There is a vital X, very critical X. Drifts means it might either be an outlier or you might see a specific pattern to the data, etc. So what do you do if that happens? You ensure that the change is detected. Your control chart will help you detect such kind of drift in the vital X. You determine what is the root cause of that. You try to eliminate it. And you'll try to ensure that the reoccurrence of this kind of cause doesn't happen. Then what is the purpose of the control plan? Control plan documents details on determining actions for maintaining vital inputs for optimum output. whatever you want to increase, sales, profitability, whatever be it, in order to get optimum output, you try to maintain the vital inputs. And for that, you determine what are the actions to be taken. You ensure through documentation, standardization, or through communicating everyone who is responsible, training them, frequently auditing, right? You do all these things to ensure that the actions that were determined earlier are followed. Then you define corrective actions if the process goes out of control. Out of control, once again, I'm repeating, if the data points fall outside the limits, or if there is a specific pattern, or we know that for attribute data, Minitab has 4 different tests which are performed. And for continuous data, we have 8 different tests which are performed. So any of these 4 or any of these 8, if they are violated, then you say that process is out of control and you take corrective actions to bring back the process in control. A good control plan will incorporate at least customer driven, critical to quality. Right? What is critical to quality to the customer? That part would be part of your control plan. Input and output variables. This is very important. We don't just plot control chart for the X's or the inputs. We also plot control chart for the outputs, that is Y's. Appropriate tolerances of specifications for CTQs should be available. We know that specification limits and control limits are different. Specification limits are provided by your customer and they do not change. Control limits are generated automatically. We have seen the formula on how to calculate the control limit. We have seen that for individual moving range chart, X bar R, X bar S chart, how do we calculate the control limits? So these control limits keep changing the moment I add more and more data. As and how data points keep getting added to this particular control chart, the control limits tend to change. Designated control methods, tools and systems, whatever you are using. Are you using SPC? Are you using a checklist to ensure that the improved process is maintained over a period of time? Are you using mistake proofing systems? Are you using some standard operating procedures, SOPs? Or are you using some kind of quality standards, manufacturing, engineering standards, right? Are you using ISO standards? Are you going ahead with CMMI, right? Or are you using some other standard, against which you will measure your performance? So all these things should be documented in your control plan. And the reaction plan. What are you going to do if something goes wrong? How do you react to a situation? That is the reaction plan. Control plan must include the information shown in this format basically. And this format is not something that is written on stone. This format tends to change over a period of time. The responsibilities must be delegated to the concerned person with proper auditing format and reaction. Look at this. Finally, this plan you are going to hand it over to the process owner. Right? And you'll ask him to follow this regularly. What is a process step? What is a control point number 1, number 2, etc.? Which is a standard that you are aligning with? What is a product characteristic? Product dimension or your iPhone? Width of the iPhone should be so much. Height of the iPhone should be so much. Those kind of things. What are the various parameters that you want to measure? Width or height, right? And how much should it be? What is your specification? What is it that the customer is asking you to maintain? Then how do you evaluate? How do you ensure that the width and height of the iPhone is maintained according to the customer specifications? Then suppose you are manufacturing 1,000 iPhones in a day, you cannot go ahead and audit or inspect all 1,000. So what would be the appropriate sample size? Are you going to pick 100 out of this or 200 out of these? Right? Depending on how many people you have for the inspection process, how many they can do in a particular day, Based on all those things, you pick up a number. Frequency. Suppose in a day there are 1000, will you audit 200 samples at the end of the day? Or will you say that while these iPhones are manufactured, say in the first hour there are 100 which are manufactured, out of this 10 immediately I'll do it. In the second hour, people manufacture another 100, so immediately I'll pick another 10. In this way, for the entire 8, 9, 10 hours, I'm going to continuously take 10 iPhones and start auditing that. That is called as frequency. You define the frequency. Control method. How are you going to control? Are you going to use statistical process control and control charts? Are you going to use a checklist? Are you going to do mistake proofing? What is it that you're going to do? And if something goes wrong, what would your response be to that? This is a simple format. Formats might change. That is the same format that is provided here. We can just go through this. This is an example. Standards and procedures. Whatever standard, ISO, right? ISO 9001, or if you are into maintenance kind of projects or support kind of projects, ISO 20000. If you are into aerospace industry, etc., you might follow AS 9100. If you are into telecom, you might follow TL 9000. So there are various standards for each and every domain or industry. Right? So you align yourself to those kind of things. Must be clearly defined and specific. Standards, whatever you're defining, standards should be very clear and specific. It should be written in a language of the person doing the work. You don't write all the technical stuff which is not well understood by your people on ground who are actually doing the work. So it should be written in a simple language. It should be easy to understand, preferably have pictures so that people might associate very easily. It includes all the procedures, right? If at all any help is required on checklists, what metrics to be captured, how should the flow diagram be of the work that they are doing, all those things. You document the standard operating procedures, means it will be standard. If I have 10 workers working in manufacturing iPhone, this standard operating procedures or work manuals or rules and specifications will clearly tell me what is that step 1, what is step 2, what is step 3, step 4, so on and so forth. It is standard. So all these 10 people should follow this particular flow. It is approved by authorities. It is not something that you document it once and people start following it. It has to be approved by proper authorities. It should include what is the purpose, what is the scope, what is the purpose of this document. It will help workers who are manufacturing iPhones. Okay. What is the scope? Scope is limited only to that department which manufactures the screen of the iPhone. What are the parameters you want to control? I want to control the height and width of the screen. What are the methods you are using? What are the measurement techniques that you want to use? Decision criteria, control method, employee health system, right? How do you ensure that the employee's health also is taken care of? In most of this oil drilling, right, there are pipelines which are set beneath the sea. At the seabed, they have the pipelines to actually transfer the oil and gas. If some leak happens there, then the employee is expected to go down 10 meters or 20 meters or however deep it is, and then do the welding part and come up. So sometimes what happens is they go with this oxygen mask. And if the oxygen completes, exhausts, even before the welding is complete, they tend to stretch a little because otherwise they have to go up, fill their oxygen, come back again. It's a tedious process. So what they do is they stretch a little. Even without oxygen, they try to do for a minute or so. But in the due course of this, a few people tend to die. So you have to take care about all these considerations. Right? One person dies, the labor union is behind you. So very, very important. Some of the pitfalls. You do not include the person doing the work in procedure development, right? Not testing the procedures before launch. So if you have a process or a procedure, what is the first step to do? Pilot it. Pilot it before doing a full launch. If without piloting, if you try to do that, then it might fail. Lastly, you validate the financial savings. Once the project is completed, the financials for the project that include both hard savings and soft savings. When I say hard savings, it's usually related to money, cost. Soft savings are like the brand image of the company has increased. Quality of the products have increased. If the quality of the product increases, obviously the sales are going to increase and there'll be a better brand image in the market. So all these things you will have to document, not just the hard savings. Now the financial analyst will review the calculations of the benefits. You might say that I, over the due course of implementing Six Sigma, I've saved $1 million to the company. But your financial analyst is going to review the calculations that have gone behind coming up with this number of 1 million and is going to validate whether the savings are true savings or not. He will then give a sign off on the document. Then the black belt of the process owner along with the financial analyst will track the savings for a period of 1 year. If you say that I'm going to save 1 million, 1 million is not going to be saved tomorrow or day after, in a week or so. It will take its own sweet time. But you extrapolate or limit it to only 1 year. So they look into 1 year of savings, right? And after 1 year, they look into what did you promise? You have promised $1 million, but in 1 year, we could save, say, $1.2 million. That's a good thing. So you'll get a bonus, probably 10% of this or 1% of this, whatever be it. At the end of 1 year, the project financial report is closed out. Training must be imparted based on the changes. Whatever changes have happened to your process, you have improved the process, right, by implementing Six Sigma. So whatever improvement has happened, right, based on that improvement, try to come up with a clear objective demonstration of skills and try to involve all the process experts and actual workers in training. You alone cannot train a team of 2000 odd people, right? So you need some kind of process experts, workers themselves, involve them in trainings. Then the interest will increase. Take the attendance basically, and also whenever a new employee joins a company, there is induction program that happens. Try to include this improved training part into your new hire training program. At last, lessons learned. What were the lessons learned? Right? Did something go wrong? Did something not go according to the plan? Document all that. Brainstorm it along with the project team. Document those things and first discuss these lessons learned with the project sponsor and the process owner, because they might sometimes feel that no, that is not a challenge at all. That is not a lesson learned. But you need to first discuss with the key stakeholders. That is the crux. Include in the final project presentation. Don't just show everything that is good. You also have to show the lessons learned to the team. And you'll have to tell them that these things should not be repeated in the future. That is where you as a consultant bring your true skills out. And if any major lessons learned, distribute to wider Six Sigma community. Take the permission from the client. Tell that since this is a major lessons learned, I want to share it with the rest of the Six Sigma communities. There are many communities on Facebook, Twitter, etc., right? Or LinkedIn. You just share it across. Right? And then we have the documentation. So documentation of the project is important to keep it as a permanent record. And share it with the members or areas with similar processes. Documentation includes finalizing the project. I am finalizing, I am signing off. with the financial results. Completing the documentation of all steps, DMAIC. That is why, in our projects also, in the previous project that you have done, we have defined, measure, analyze, improve, control, everything that you have to do. You also have to document it. So if you go through that project carefully, there will be the documentation part also. Getting the approval of the customer, concerned authorities on project closure, it's very, very important. Document any lessons learned for future exercises and store it in the common repository. Finally, store the project details in the central repository, which is called as OPA, Organizational Process Assets. Save all the documents, whatever you have, place it there. Why are you placing it there? Because tomorrow if someone wants to implement a similar kind of Six Sigma project, they should be able to readily refer to all these things and get the job done. Finally, there will be handover meeting. Schedule a project handoff meeting with the process owner. You're not going to stay there and control the process, improved process throughout, right? You're a consultant. Your role is limited to just giving them the improvements and moving ahead. So the project is handed over with documentation and control plan to the process owner. Any changes recommended are incorporated and monitoring methods are discussed. Yeah, so this is the sign-off event wherein you say, I agree that the Six Sigma project is completed. I have reviewed the financial benefits. Financial analyst will say. Then Master Black Belt will say, I have reviewed this project and I certify that the Black Belt project has used appropriate tools. Then the sponsor finally says, yes, I'm okay because process owner, financial analyst, Master Black Belt, everyone have signed off. Here is a formal sign off from my end. And then you close it. Yeah, here is a summary of the control phase. You have developed the control plan. You have finalized the financial results. You have completed the training of the improved process. You have documented everything that you have done until now. You updated those documented details in your organizational repository, and you also documented your lessons learned. Right. So I think we can. I'll stop here, Anuj, and tomorrow we can start afresh on 2 exercises and the project. So today, tomorrow, I think we should be done. Sorry, tomorrow and day after we should be done. All right. That was pretty theoretical, but yeah, tomorrow morning, yes.